Hey there, it's Max. This is the 6th year of the Spokane Cyber Cup, and we're going through challenge number 3 of the Smart Contract series. So, in the previous 2 challenges, we interacted with and deployed or created a smart contract. We haven't done any real exploitation at this point. So, this is where we start turning to more of a security take on it. So, this challenge is called donation. It says a blockchain project has created a donation smart contract. Users can donate ETH, or the native currency of the Ethereum blockchain, to the contract for the cause. At the end, the developer can withdraw these funds or take them out of the smart contract to fund their project. Can you steal the funds from the developer there in the contract? To win, steal all of the Ether from the smart contract. Hence, public/external functions can be called by anyone, while private and internal cannot be called from outside the contract. Use remix and interact with smart contract again. Cool. So, like before, we're going to deploy our smart contract. And then we can go back to remix, and we can look at the donation code. So, first, when the contract's deployed, it has some sort of balance field. Now, this total balance is the amount of ETH that's in the contract. And this is passed in via message.value, which is a special global variable that you can't control yourself besides by sending Ethereum to it. The receive function is used for actually receiving funds via a transfer. There is a special function for doing that because you may want to reject it or have special functionality for doing that. Without having a receive or a fallback, you're actually unable to receive funds as a smart contract with the normal interactions like this one. We have the donate function, which looks very similar to the constructor. It's just doing total balance plus equals message.value. And although this is actually keeping track of the balance, you can actually, the Ether itself isn't stored in total balance. It's just kept there. Cool, so you can call receive or donate to do that. And then there's a withdraw function. The withdraw function will take all the Ether from the contract, but of course it wants to make sure that the amount is less than the total balance. It will then subtract it from the balance and then do a message.sender.call right here to send the funds to the particular user. And finally, of course, we have the win function, which is checking to see if the total balance of the smart contract is 0. And this is important because message.balance right here, it's not message.balance, the address of this .balance is checking the actual amount of Ether in the contract. This should be the same as total balance, but I just decided to make sure it was in this case. So the vulnerability here is pretty classic. It is just a missing access control bug. And you see that all the time in web applications where there just aren't really simple checks. So the issue is that while anybody can donate, I don't know why that jumped there, anybody can also withdraw funds. So if there's 5 Ether or something in the smart contract, that's a problem because you can just withdraw it. There's no check to see that there's an admin or something like that. That is the only one who can withdraw this. So we currently have the donation contract up. We want to specify that it's at this address. There's a couple things we can call. We can call total balance on it. Which I don't know why they didn't return anything. Maybe I didn't get the right contract address. Okay, we'll try that again. Sometimes Remix can clog up, and I don't know why, and I just have to refresh the page. I'm guessing that is one of those cases. So before we do that, we of course need to move this back to the external provider that we were talking about. We need to reopen the donation smart contract, which will then auto-compile according to this setting here. And then we can set at address and try again. Cool. So that time the total balance is shown. It should be noted that in Ethereum, there is no such thing as floats. This is because floats are weird, they're architecture dependent. So we use what's called fixed point arithmetic. It's like how we deal with the US dollar. The US dollar has cents, but also has dollars. A lot of times we talk in dollars, and when we say, "Oh, I bought this thing for $19.99," you can actually speak of that in cents. And it's the same thing with Ethereum. There's different denominations of it. So Wei is exactly a single one of this, while Ether is actually 10 to the 18th power Ether. In this case, I'm actually not sure how much we have, but we can do Ether amount converter, and we can quickly see this. So you can see there's actually quite a few. There's Wei, Gwei, Ether, and if I type in the Wei here, we notice this is 0.1 Ether is all is in the contract. Cool, so now that we know that, we can just withdraw that amount. If you try doing anything over that amount, then the contract execution would fail. And we can actually see the error, why? Too much money being withdrawn. But if we draw the exact amount, then it should succeed eventually. Froze up again. Gosh dang it. All right, go one more shot. All right, got to open up the donation smart contract. We're on the right provider. We have to get our address again, and then we have to do add address. We can do total balance to get the balance amount, and then we can do withdraw, and we can see this succeeded. If we call total balance again, it is set to 0, and that is the win function. So that tells us that this indeed did succeed. We were able to take all of the Ether from the contract. So now if we go back to EVM donation, we did win, and we did win. Woo! We succeeded. We got the flag on this. So to recap, there's just no access control on this withdraw function. So once we know the amount, we can get by looking at the total balance, which is a public variable. We can then pass that in here and just withdraw all the money from the contract, or all of the Ether from the contract to be more specific. Cool. So hope that was a good one. See you in the next video.